Okay, welcome. Awesome, thanks for coming. My name is Martin Lippert. I work for Pivotal. That's a US company behind Cloud Foundry, Pivotal Cloud Foundry, and Spring Boot, Spring Cloud, Big Data Suite, and so on. So all the Spring group was working for Pivotal. That's why I'm working for Pivotal, because I'm working in the team that is doing the Spring IDE and Spring Tool Suite for Eclipse. So all the Eclipse-based tooling is done on my team, and that's what I would like to talk about a little bit. But before we start, I would like to invite you to a quick journey, because I would like to talk about cloud-native applications, so applications of the next generation, applications that are built for the cloud. And that's actually interesting how that affects the IDE, at least from my point of view and from my first ideas and the ideas of the team. But before we go there, we go back a little bit in time. We go back in time when computers looked like this. I don't know if you had a machine like that on your desk before some time back. Actually, that was roughly the time when Eclipse got invented. So the first versions of Eclipse were built on those machines. And all the ideas about the IDEs and the ideas about Eclipse, how Eclipse might look like and should look like, were all thought out in that age, in that maybe in century, right? That's interesting. If we take a look how applications looked like back then, you might remember applications like this. So one of the greatest inventions in computer history, in computer science, Eclipse, right? Maybe you remember that little annoying guy in Word. One of the worst moments in computer history, I guess. Actually, Eclipse looked like that, right? First version of Eclipse, Eclipse 1.0. You might see things that look familiar with Eclipse today, but not a lot. The first website looked like this, so real HTML, right? Handcrafted HTML stuff. Even Yahoo looked a little bit outdated from today's point of view. Google, more or less the same than today. Not much of a difference. And this was actually the page where you downloaded Java at that time. So also slightly different than today. You didn't have to agree to the Oracle license agreement, for example, but anyway, Java 1.4 beta, wow, amazing. What about today? What has changed? I think a lot has changed. Today, applications are built for the cloud, and especially the modern and big applications behind Twitter, behind Facebook, behind Google Mail, whatever, they are all built for the cloud. And they are built totally differently. And if you take a look how applications look like, maybe they look like this, right? This is a web application or web interface for today's cloud-native applications, for example, Netflix. And that's I think such a good example, because we treat Netflix stuff because they're quite open. They open source the libraries, they tell everybody how they work and how the applications are being built, how the architecture behind those cloud-native applications could look like and might look like. And the architecture behind these cloud-native apps consists out of applications that run independently of each other. Today we might call them microservices to be hype compatible, small individual components talking to each other. And there's even something like a chaos monkey, so someone shooting down services randomly, but the system has to stay up and do this kind of the same quality of service as before, even though individual components fail, they being shut down or whatever. So they really created this kind of resilient system out of these microservices and running on top of I think a great cloud platform. I think at least today running on the Amazon cloud. So the way we build these applications changed dramatically, right? From 15 years ago to today. But what does it mean for application development? Actually for building those kind of applications. Does it make sense that IDEs look exactly the same than 15 years ago? Even though the applications that we built, they look totally different, being built with a totally different architecture. So what we did is we ask people, what should we do? We ask our users, people building these kind of Netflix, cloud-native apps. Many of them are using Spring Boot and Spring Cloud. So what do you need? And they told us, yeah, all fine, Java editing is great, Java is perfect, Java IDE is great, we don't need anything else. Oh yeah, maybe we need nice properties editing and content assist for property files and for YAML files and things like that. And we did that, right? We went back to the old STS IDE, added these, let's say, common features that you all know from Java development to some specific Spring Boot stuff like YAML configurations for your Spring Boot app, for a Spring Boot microservice. But is that really all? So we went back and thought about how do those applications look like. And the first observation that we came across is you're no longer working in your IDE with a few projects, with a few maybe big projects. And you're shipping those few big projects and running them in a local Tomcat and that's it, or something like that. You are working with many small components and possibly many of those projects. Small individual things, they're talking to each other, but many of them. Not just one or two, maybe 20, maybe 30, maybe 50 components that you're working on. Maybe not, hopefully not on 50 components at the same time, all the time while coding. But the viewpoint has changed. Right? The viewpoint is a set of possibly a large number of components. And while doing that, you do not stop the application, you change the application, then you start everything up again. That doesn't make sense anymore in a cloud-native world. More or less, all the time you have your system running, for example, on your local machine. You have everything running, and then you pick a specific service or a specific part of your system, you work on that, you restart that, but you keep everything else running. So the viewpoint turns a little bit towards working with a lot of running components instead of static code, typing something in, and then, oh, let's start it up and test it. And then you start it up and test it, and then, oh, you shut it down again, continue to work for an hour, and then you start it up again. That's not the way usually these cloud-native apps are being built. And when I say you might have running everything locally, that might not always be the case, because running everything locally could be quite hard. These 50, 60 components running on your local system, having data backends running on your local system, messaging queues and whatever, that's quite a burden. And maybe you don't need that. So you might want to actually shift a lot of those, let's say, running applications towards the cloud environment that this is built for. So having the system running on the cloud, inside the cloud environment, and you choose to pick certain components that you work on locally. Maybe not just one, maybe 2, 3, 4, 5, multiple, but you pick certain things and not everything. And I think that changes the way we work with IDEs a little bit. That changes the way we work with microservices and IDEs. And that's what made us think about, let's go back a step and rethink what people are actually doing and how we can help them. And we came up with an idea that is simple. It's totally simple. And you might even think of, this is too simple. This is too stupid. He can't really stand there and tell us, oh, this button is awesome. But we showed this piece to people, and we gave it early adopters inside our company in the community. And they said, oh yeah, that's something that we never thought of that we need, but since you showed us what's possible and what we can do with it, I will not be able to live without that anymore. So this is quite an awesome thing, but you will be surprised how simple it actually is. So let me switch to my IDE and show you what we've done. So this is STS, it's Eclipse IDE, added on with Spring tooling and so on. And I have a few applications here. That's a fortune teller, right? It tells you what will happen in the future. Quite an awesome application. It consists out of multiple parts. There's a service registry, something you usually use. It's using Eureka, so Netflix open source libraries. There's a service providing you with the exact predictions of the future. There's a UI for a website telling you what the future will look like and things like that. To get everything running, it's actually quite complicated here, right? You have to click saying, oh yeah, run as, select a port maybe and go on, and then you start up the application, and then you go to the console usually, and you try to find out where's the port that this Tomcat is running on, and things like that. But we created this tiny little magic button, right? This tiny little magic button, which is called the boot dashboard. This is simple, nothing really fancy, but the boot dashboard actually shows you everything that's inside of your workspace that's a Spring Boot project. So it assumes, oh, this is a Spring Boot project, looks like a microservice thing, I will give it to you. So here's a list of Spring Boot projects. And what I can do now is I can just select multiple apps here. For example, all those three, and I can just press start. So it's the easiest way to start up your Spring Boot project in Eclipse. It's just one click away, right? You select the project, you press start, and since in my cloudy world, I usually do not start up 1 or 2, maybe I start up 3, 5, 10 applications at the same time, I can just select all of them, press start, done, right? And now I see the log output in the console, that's nothing unusual. I can see, oh, those apps are running, the other apps are not running on my local machine. It's a quite nice overview. And I can jump to the console. So let's take a look at what the Eureka stuff printed on the console. Just jump to the console. Doesn't work. Jump to the other one. Jump to the next one. So you can usually jump around between those console outputs. In this case, all using Spring Boot, so do not look different. But in addition to jumping to the console, it also tells you automatically on which port this app is running. So you can see, oh, I have three services running. Those are running on different ports, right? So that's easy. You do not have to take a look at the log output, whatever. Just see, oh yeah, it's running on port X, Y, and Z. And that is maybe easy for 3 apps. It's a lot better if you have 10 or 20 services running. But that's not all. Usually, if you implement your service, you would like to try it out. You would like to use it. So what do people do? Yeah, I open a web browser. I type in localhost colon and 8080 / whatever. We should make it easier, right? Save you a little more time. Saving 5 more seconds of your life every day. So you can just double click. And it opens up a web browser jumping to the right thing. In this case, it's quite boring because the service does not provide an index page. It serves different REST endpoints, but not a default one. So let's go back here and take a look at the properties of this app. So I can see the properties, and I can type in something like the default path. So whenever I double click, I would like to jump to, let's say, random. Oh, and I get content assist for all the endpoints that are provided by this application. That's nice. That's easy. I don't need to know exactly what endpoints are being provided, what are being implemented inside of this application. I just get content assist. And I see all of them. So I say, oh yeah, let's use the random one. So whenever I do double click on this app, it jumps to the random endpoint of this application. Not working in my random endpoint, so let's take a look where this is defined. So I can take a look, all my endpoints of my running application are being defined. Those 2 are being defined in my source code. The other ones are being defined in libraries. And lead to the source code where random is being defined. So I can just double click here and it jumps to the source code where in my project the random endpoint is being defined. So it helps you navigate quickly for those request mappings that you have inside your application. I also said that the services that you have in your workspace give me quite a number of applications, maybe 5, maybe 10, maybe 50. And you usually maybe don't want to work on all of them. So you can tag them. You can just put random tags of your choice on your projects. All right, in this case. So I tagged 3 of them. So if I do a filter, fortune, it just filters out to the set that I'm really interested in at the moment. So this is nice. A number of nice features that are itself, each individual feature is not really a brand new world invention where you get the Nobel Prize for, right? But each of those actions saves you 5 or 10 seconds every minute. So if you count that up, people will not live without those things. Even people showed up and say, at the previous conference where I was showed, this is the reason why I will switch from IntelliJ to Eclipse, just because of this. So it's so easy for people to work with their Spring Boot applications. But I also said that working with apps locally is not enough in all cases. So you have your cloud, and you would like to work with your cloud. So you can do that. You can add a cloud environment to your boot dashboard, and in this case for Cloud Foundry. Let me try to type in my credentials. Select a space. Now cross your fingers for the network. Now's the risky part of the presentation. Here we are. So it shows up as a separate section in my tree view. That's my Cloud Foundry environment that I have running on Amazon. It's a publicly Cloud Foundry environment, the PWS environment, the Pivotal Web Services environment that you can all get an account for if you want. Nothing in there, at least not in this space. So let me quickly try to deploy the apps. So I just drag and drop them over, and that starts to deploy those apps to Cloud Foundry. That's all I need to do. I don't have to go back to the command line, do some magic pushes, select X, Y, Z, whatever. There's a manifest in each of those projects, and the manifest is defined how this application should be deployed, so what number of instances should be running on Cloud Foundry, what's the space, the heap space, and then all that stuff. So I can see all those 3 things are starting up. And starting those things up takes quite a while on Cloud Foundry. That's why running everything on Cloud Foundry all the time and then working purely on Cloud Foundry can be quite annoying if you make a change and you have to redeploy. You wait for 5 minutes or 10, and then, wow, that's fast. So that could be annoying. But you can drag and drop them, you can deploy that, and we try to provide you for those applications with the same kind of experience than with the local apps. So you can tag them, they get filtered. You can put the default path random, for example in this case, on one of those apps, and if you double click, once the app is up and running, it opens up a browser, jumps to that endpoint. So you get the same features available. You can start apps, you can stop apps. In addition, you can also delete them from Cloud Foundry again, and you can jump to the console output of those apps. So let's see what the Eureka one is doing. Oh, that's already starting up the Spring app, so that looks great. What the Service app is doing, that's also starting up. That's good, and the other one seems to start up as well. So it looks like we are close. The public Cloud Foundry version is healthy and happy today and provides me with a good experience getting up quickly. So all the apps are running, so I can double click here. It opens up the browser, showing me the live running app on Cloud Foundry, just from my IDE. So that's great. Perfect. There is something like the same experience now for your remote apps running on the cloud. So that's great. But as I said, if you want to work on them and you want to change them, it could be quite annoying to redeploy the app on the cloud all the time, right? That's why you usually start to work on stuff locally. Let me stop all the other ones. But what's there is a piece in Spring Boot, which is specific to Spring Boot. It's called the Boot DevTools. That's a tiny little piece you can add to every Spring Boot project. And that allows you to restart your app quickly if a class file changes. So you can use it locally, right? Usually it's not really worth doing it locally because you can change your class file in your app, and under the hood the application will be restarted. So you're losing state, but it's really quick. It quickly restarts. So what we did for the dashboard here is we added the same experience for the cloud one. So you can just simply from the dashboard, you can start something like the remote connector for the dashboard, for the DevTools. So if you have deployed an app to Cloud Foundry with Spring Boot DevTools enabled, which means Spring Boot DevTools is on the class path of this app, you can just start a local, let's say a local version of that on your machine. Let me switch back to that local version. That's here, right? And whenever I go and change something, so let me change the service here. This is a static answer. So I'm going to press save. The change class files are now being uploaded to Cloud Foundry automatically for you, just the change class files. And on the Cloud Foundry side, the DevTools take care of restarting the app automatically for you. There is sometimes it's a bit strange because Cloud Foundry figures out, oh, the app is down and restarts it in between. So sometimes it does not really work. So we are working on that part you can disable the health check. So that's a solution for that. But under the hood, the app gets restarted, right? And that's usually a lot quicker than redeploying the whole app, because if you redeploy the whole app to something like Cloud Foundry or your cloud environment, usually the container gets created again, everything's being put together, it's starting up, so it takes a while. If you just restart your app, that's quick, and it's already done, right? Health check is passed, it started up the app, and in the case that the health check does not hit the app in between, and it's just DevTools going on there, it's even quicker. It's really good. So let's see if I can do even more here, and see what's going on the app side. You see, quickly the DevTools got these change class files, restarting the app quickly, and this is, I think, the use case that hopefully works purely from within the app. And let's see if that worked. Yeah, the app is changed on Cloud Foundry very quickly. So that allows you a quick turnaround cycle, even for Spring Boot apps that are running on Cloud Foundry from within the dashboard. Okay. Let me shut that down again and do something else. I also said that for the microservice world, you sometimes have everything locally, sometimes you have everything running on the cloud, but sometimes you would like to get something like a mixture. You would like to say, oh, I have everything running on the cloud, but this one service, I would like to work on that locally. And I don't want to push changes to the cloud all the time, whatever, to try things out, because, for example, I would like to do real fast debugging and step through everything locally with a real fast machine, and do not jump over the wall to the cloud and debug inside the cloud, which could be, it works, and we have that working as well, but it could be really annoying. The debugger protocol and experience of Eclipse and Java is not really built for debugging into the cloud and into such a container, usually. So what you can do, what we added is, you can start up your local application and expose it to the internet with a reverse proxy mechanism called Dangrok. That's a publicly available service, everybody can use it. It allows you to expose something that's running locally to the internet, and that's going to be available in a specific URL. And since we have a service registry running on the cloud, that's part of the cloud native app, right? There's the Eureka service registry that registers where each service is. We can register this locally running service that's being exposed to the internet with this service registry. over there inside the cloud. That's why this dialog is coming up, and I select, yes, please register my local service with this remote service registry on Cloud Foundry. And that's what happens, right? The local app starts up in debug mode in this case, and it registers itself with Eureka. That's what usually happens, right? Usually it would register with my locally running Eureka. Oh, there's an exception, no problem, that's all fine. But for this case, it isn't registered with my local Eureka. It's being exposed under this URL with ngrok and automatically registered with the remote Eureka. So if I take a look at the remote Eureka, the remote service registry, I will see that there are two services registered. One is the UI, one is the Fortune service itself. The UI, that's the UI application, and there are two instances available for my service. One is the one on Cloud Foundry, one is my locally running that's being exposed. So what I can do now is, there's a breakpoint, right? And if I use the application on Cloud Foundry, all the services that are running on Cloud Foundry, which I will do now, I will just jump to this Fortune Teller service, Fortune Teller UI. The UI calls the service, and in this case, it calls the instance that I registered, which is my local one, so it calls my local services running on my machine, and I can debug through it, through everything locally on my machine, change even some stuff here, so let's do, in case you don't trust me, let's quickly change the value of this. This is local. Right. Okay, continue. If I go back to the browser, it tells me, oh, this is local. But this is the app that's running on Cloud Foundry, right? But it called out to my local service that I'm working on my machine. And we tried to make this easy accessible from your local workspace, from this tiny little boot dashboard that becomes something like, let's say, your microservice dev center, right? That's a starting point. You can easily start things up, you can stop them, you can jump to the output, you can expose them, you can debug them. It gives you all you need. And I think that's, it looks stupid if you take a look at that and say, oh, there's a start and stop button. Wow, that's innovation. But it really saves you these 5 seconds every time, which I think is great. Okay, so that's the demo part. And now I would be very happy to answer questions. And I forgot to tell you, you can ask questions anytime, but nobody did, so maybe because I forgot to say that. Questions? Question and answers. Maybe answers. Who knows? No questions. Okay. Hope you like it. If you want to try it out, that's inside of the latest STS version, so you can just download it. Cloud Foundry adapter is just the first one that we built, so if you have your cloud on Amazon or your cloud on Azure or your cloud on wherever, it's totally possible to implement something that injects the same thing into the boot. If you like it, and thanks for coming.